Anyone who has reasoning model expertise is considered as important and as expensive as a football player now.
So like the future that we're building towards is as kind of like a task list with superpowers. That anytime you think of to do or a task that you have to do on the go while you're commuting or in between meetings, you jot it down somewhere. And then behind the scenes, there's like agents or assistants that are making progress on those tasks on your behalf.
When Devi and I started our PhDs in the mid 2000s, you didn't use the word AI because it was not a respectable word to use. Kooks and crazy people use the word AI.
Yeah, I finished my PhD in 2020. My thesis was called Building Agents That Can See, Talk, and Act. It was the runner-up for the AAAI Dissertation Award.
Why?
As in, why did you not win it? Or
No, why you got it? What was special about it, right?
The Indian parent energy that
Why didn't you win? I mean, good point. I mean,
why did you come second? Right?
yeah, why second? Why not first? Most of the students out there, like, forget PhD, they're dropping out of college. What is your perspective on that?
there's a bodybuilder whose name is escaping me right now. He has a famous quote, everybody want to be big, nobody want to lift big ass weights.
So true. So true. So Alan Turing Award winner person taught you that excited you to move closer towards PhD and actually go for it.
Yeah, that.
So hello everyone, today I am with the team behind Yutori. This is a product that I use every single week. Let's say I want to, keep track of my favorite Levi's jeans. It is out of stock. I can create a scout. I can create an alert. It'll email me whenever I get the notification, oh, this jeans is available. And my favorite feature, whenever I want to, keep in track of the conferences happening in China and the US, let's say robotics, all the conferences, or maybe I want to keep in track of trends of H-1B visa, F-1 visa. Every week it collects only that data and sends me. It doesn't hallucinate much. It's so well crafted. It blows my mind. And right now I'm surrounded by researchers and scientists who have 50 plus years of research combined. And it's just fascinating. Especially Dhruv and Devi, they have experience as associate professors as well. So we are surrounded by scientists plus professors. Can you please, first of all, share what is the knowledge you have by having the expertise in academia as well as research and now being founder as well that other people do not?
Yeah, I can take a stab at it and both of you should add. But maybe one thing that comes with it is a bit of a perspective on how trends tend to change. Having been in the field for 20 years, we've been around times when not much progress is happening on a year-to-year basis, not even months. Every year you go to conferences and like performance goes up a tiny bit. And then we saw the first wave of deep learning excitement around 2012, 2013. Mm-hmm. And at the time, it felt like this is crazy. Progress is so much faster. Talent wars, all of the kinds of things that we talk about right now was very much happening then. It's a different scale now, but at the time, that had felt like an order of magnitude more than before it. And then sort of with ChatGPT and all of that in the last 2 years is sort of the second curve of that happening. And so I think just this perspective that even if it feels like things are crazy, you can have a little bit of baseline calmness associated with it and kind of follow through on whatever it is that you're excited about. Maybe that's one perspective that we get out of it.
So you see the shortage of researchers like you see the hype because you've gone through the second wave as well now.
Yeah. Time did not start in 2022 and AI research didn't start in 2022, which is tracing the history of ideas back. The fact that we should build intelligent machines that can perceive the world around them, that can communicate with humans in language, that can solve problems that humans can solve, everything from puzzles to physical intelligence of picking objects up. That has been the goal since, the first Dartmouth workshop on AI, where the phrase artificial intelligence was coined in the 1950s, is if my recollection serves right. When Devi and I started our PhDs in the mid 2000s, you didn't use the word AI because it was not a respectable word to use. You were not considered a respectable scientist if you said AI. You said you were working on the machine learning because that was mathematically rigorous, and kooks and crazy people use the word AGI. I just find it a bit, I'm impressed and continue to be impressed by the progress that we've made as a community, but I find it a bit alarming at how we seem to lose sight of the bigger picture. There are still lots of problems that we have not solved, and there are lots of questions that we haven't even begun to ask.
And we see the like hype exponentially high with this extremely high shortage of reasoning expertise, which Meta told us by giving $100 million offers. They told that anyone who has reasoning model expertise, we have in this room right now again, is considered as important and as expensive as a football player now.
I don't know. I mean, we're playing a very different game, right? Like, we're not in the same space where we can make $100 million offers, if at all those kinds of offers were made. Yeah, it's a very interesting word. Like, I got into machine learning and AI in 2015. I started my PhD in 2016, and ImageNet had happened. The first set of image captioning papers had come out, which were basically like AI models that could write one-sentence descriptions about images. And back then it felt like we were very much on an exponential curve, because every year there would be more and more industry presence at conferences and so on. So it was one S-curve, and like 2020, 2021 onwards, it felt like there was a clear transition to a different exponential curve after like GPT and ChatGPT. The Meta, like the recent set of offers that have been going on, like it feels like on point in that exponential, like that second or third exponential that we're on already. I don't know if there's,
And I think to your question of that, like what is unique, not just the three of us, but like overall the team that we put together, I think right now there's a whole lot of effort that goes into sort of the app layer, that like taking models as they are and building applications around it. And then there are a small number of teams that have the research background similar to ours, even stronger in some cases, but there the focus is much more on the models itself. And I think one thing that's unique about both the things that Yutori is going after, and as a consequence, the team that we've put together is innovating across the stack. We're pushing on the underlying model capabilities, and to your point, thinking through product experiences to build products that are reliable and that are well designed and easy to use on a day-to-day, on a week-to-week basis. And that intersection, I think, is relatively uncommon in everything that's going on in AI right now.
Absolutely. We can see many AI startups, but no other startup can match the level of understanding of models that goes behind the scenes you guys have. You have worked so closely with the models. To add on, like, especially your research, all three of you have worked at Meta. You have worked at the lab called FAIR, which is fundamental AI research, which gave us PyTorch, which gave us Llama open source models, which have revolutionized, in the AI space. So most importantly, deep understanding of those models is extremely rare. And with that understanding, what I have seen with Yutori, you have not just created browser agents, which are basically a software layer, but also at the same time created your own models behind the scenes, which act for you. You guys spent months on actually crafting your idea. I saw your LinkedIn post. You started the startup 1.5 years ago when you all left Meta, but you spent 6 to 7 months to craft this idea. That gives me an epiphany that AI is still not creative enough to give you that idea. You had to spend months to craft, to fine tune that idea that you want to work on, Yutori. Can you share how you came up with this idea and why it took months to figure it out that you want to work on it?
So I think one thing that's relevant here is that what Yutori is going after in the longer term is sort of this AI chief of staff, this assistant that is taking care of all the mundane digital chores for you. And in that form, there's a whole lot of things that it can be doing. Models today aren't ready enough to be able to deliver on all of that reliably. And so it's important to put something out there, or at least it was important to us to put something out there as the first thing that is directionally aligned with that, but is sufficiently well scoped that it can be reliable. We didn't, like, you see a whole bunch of demos on Twitter or LinkedIn or other places where it looks amazing, but then you try it out and then it doesn't really work. And then you got to never go back to it again. And there's so much of that we didn't want to be an additional data point in that space. And so it was important to think through what is the product use case that is directionally aligned with where we are headed, that will be delightful, that will feel magical, that will be very useful, and is reliable, and people come back to it every day. And that's not something that at least us and the team could get to in just like a few days, right? It takes some thought to figure that out.
Just to add to that, we're kind of in an interesting time where it takes like one day or like a day or two to put together a demo, and then it takes like months to get it to the level of reliability where it makes sense to productize it, right? So the promise or the value proposition of our first product, Scouts, which is basically agents that can monitor the web for anything, it's very simple, very clear, right? But to deliver on that product, the level of innovation, because it is quite broad, right? To deliver on that product, the level of innovation or the work that goes into making the underlying AI infrastructure reliable takes months. That is where the secret sauce lies. Web agents are not at a like it's on the capability side of things. It's not at a to what Devi was saying. It's not quite at the point where it's just ready and all that's left to be done is productizing it. We are pushing both on the research front as well as the product front, and kind of in a vertically integrated manner to make it all work. There's a lot that goes into making it all work.
Yeah, great products takes months, and ideas can be shown in few minutes thanks to AI, but products still takes months to craft, which you have proved.
I think when we started a year and a quarter ago, one example we used to use is autonomous driving and self-driving, and how the history of that field traces back to 2005, 2006, the first DARPA Grand Challenges, where in the first year, not a single autonomous car finished the race, but in the second year, you had multiple cars drive from point A to point B in a desert while the location was unknown ahead of time. It takes a few years from there for those researchers to get absorbed into Google. Waymo spins out. 2010-11 is when Cruise gets created and a couple of other startups form. And it's not till like 2022, 2023, till the app Waymo comes out where you can actually call it in your city. It's still not nationwide available, but I want people to realize what it takes from a research demo in mid 2000s to a product that people can use. And the reason is autonomous driving has the same phenomena that he was pointing out. It is extremely easy to build a demo, but dealing with the long tail of traffic that you experience, it forces you to work through problems that take many, many years to figure out. Fortunately, in our case, this is pure software. This is not hardware, so the cycles are faster, but the behavior is similar. We cannot, and people promising anything and everything are fundamentally misrepresenting the claims of their product, which is why our first product has to be exposed to the diversity of websites. Websites are laid out extremely differently. They're laid out for human consumption. There are certain design patterns that you and I understand that designers of websites create. So one example is that when you go to a website and if there is ever a date or a time and that time is grayed out, that is not available. So if you're looking at a list of availability on a website, some of them are grayed out, some of them are dark. You know that you're not supposed to click on the grayed out or struck through times. How does a model know this? That's just an implicit design pattern. There's no text there that says not available. Those are the kinds of patterns that you have to learn, that you get exposed to over time. And that's the long tail that we have to figure out with browser use models. And the way to get there is the Tesla pathway than the Waymo pathway, which is you provide something that provides immediate value, which in our case is Scouts, a narrow use case, but that exposes you to the diversity of traffic over web, and you grow incrementally from there with an upskilling in the agentic capabilities.
I want to highlight how we have 50 years of research experience here once again. We have Abhishek, who has worked under Devi and Dhruv during your PhD at Georgia Tech. You got the dissertation triple AI award, which is the doctoral dissertation.
I was the runner-up.
Huh?
I was the runner-up.
That is extremely rare. And especially Devi, who has the Nobel Prize of Computing Award, which is known as the IGCAI Computers and Thought Award that you got in 2017. And you got 100,000 plus citations. Can you...
The Nobel Prize, I think, it's another league. It is a notable award, but yeah.
So can we please talk about your prior accomplishments that brought you here?
I've been working in AI for about 20 years. My background was in computer vision, which is that's what I did my PhD in. Over time, I started getting interested in finding ways in which people can interact with these machines more naturally. That's how I transitioned from computer vision to multimodal problems at the intersection of vision and language. So you can ask systems to describe images in sentences, answer questions about images, have a conversation about images, and so on. And then over time, I got interested in seeing if we can use AI as a tool for creative expression, as a sort of for enhancing human creative expression. And that's how I started working in generative models for images, video, music, and other modalities. I was in academia for a while. After my PhD, I spent a few years in Chicago at TTI Chicago. And then I was faculty at Virginia Tech and then Georgia Tech. And then I was at Meta for about 8 years. For the first 5 or so years in FAIR, originally Facebook AI Research, now the Fundamental AI Research Organization at Meta. And then I was in Gen AI for a few years, where I was a senior director leading the multimodal research efforts there. So models like EMU Video, EMU Edit for image and video generation and editing were coming from my teams. The multimodal capabilities in Llama 3 were coming from my teams as well.
EMU video editing? What is
EMU? Yeah, EMU was the image generation model out of Meta. EMU Video was a video generation model coming out of Meta as well. EMU Edit was like an image editing model that had come out of Meta. I don't know if that name series is being continued now. But at least at the time, that's what they were called.
And now they acquired Midjourney, which we'll talk later. But yeah.
Yeah, I can go over my background as well. So I grew up in India, moved to the US in 2016 for my PhD. Dhruv was my PhD advisor at Georgia Tech. Devi and Dhruv used to run the lab together. The three of us worked together a whole bunch as part of my PhD. At the time, I was working on problems at the intersection of computer vision, language, and reinforcement learning. So as an example, if you think of a home robot and asking it the question, where did I leave my keys? In order to answer that question, the robot would need to understand language. It would need to know how to navigate an indoor environment and then come back to you with the answer or with the object that you asked about. And I was looking at how do we train deep learning models for these kinds of tasks. This is back in like 2016, 17. So AI systems weren't anywhere close to as capable as they are today. So it was a fairly early exploratory space to be working in. I had a lot of fun in my PhD. Like I interned at a bunch of places. I spent some time at FAIR at Meta. I spent some time at Tesla Autopilot at DeepMind. So had a varied set of experiences. Finished my PhD in 2020. My thesis was called Building Agents That Can See, Talk, and Act. To what you were saying earlier.
So agents were big in 2020 starting.
Agents meant, agents have been around especially in the reinforcement learning literature for a while, but they've meant a very specific class of problems in machine learning research, more to do with like sequential decision-making tasks. Now it's more of a buzzword and more overloaded, and like people use it to refer to like browser automations or cron jobs to more researchy things. It's definitely more used now, but agents have been around for a while. I finished my PhD in 2020. My thesis was called Building Agents. It was the runner-up for the AAAI Dissertation Award.
Why?
As in, why did you not win it? Or
no, why you got it? What was special about it, right?
The Indian parent energy. Why didn't you win?
Good point.
Why did you come second? Right?
Yeah, why second? Why not first?
I mean, Noam Brown won it that year. I think it's very well deserved for the work that he's done. Why did I end up winning or being the runner? Some people thought it was worthy of an award. I don't know.
So his work 10 years ago was one of the first ones to extend machine learning neural models from just answering questions about a single images to answering a sequence of questions, so holding a dialogue today we think chatbots are solved. You can upload a picture into ChatGPT. 10 years ago, that was an open research problem. His work was one of the first ones to build a data set, have an evaluation criteria, build the first few models, train them with self-play with reinforcement learning. So he proposed a set of experiments where there were two agents. One would hide an image amongst others in a sequence of lineup. The other agent would try to guess it. And so there was self-play for training these agents. And so language-based self-play was extremely new at that time. We did not know how to make that work, and his work was at the cutting edge of that. And the way I described his thesis to people was that it almost went through, there's two PhD theses in there. There's one on answering questions about images and holding dialogue. There's another about building agents that can navigate and then answer questions. So you drop a virtual robot in a house and it has to navigate. And like any one of those pieces would have been upheld as a body of work on its own. Together, it is extremely impressive.
And interestingly, that arc of sort of going from these chatbots talking about images to them navigating and doing all of that, that urge was coming from that, like, these entities that just talk to you is not sufficient. You want them to actually do something for you. And that thread, I think, exists in the work that we're doing at Yutori as well, that a lot of these assistants right now, you can chat with them, but you can't get them to do things for you. Which is what we're going after now. So it's an interesting parallel.
We take it lightly when we talk with like image models like Nano Banana. We can have a conversation follow up, but you are the one who pioneered in this research that you can have a continuous agentic chat with an image, point towards some details, and carry out a conversation, which was extremely new. And you were unfortunately runner-up.
Yeah. If I had, I don't know, like if I had landed on the scale hypothesis as part of my PhD, maybe I would have won it. I don't know. So I feel like I missed out on that.
I'm an AI researcher as well. Been in the field roughly 20 years. I'm easily nerd sniped, and by that what I mean is I have broad interests and I tend to follow them for a few years and then switch, get interested in something else and switch. So most of my early work was on core machine learning applied to computer vision problems like segmenting objects and images. Then for a few years with these folks, I was working on building chatbots that can answer questions about images. The three of us actually, together with our other co-authors, did one of the earliest works on neural network interpretability. So showing where in an image a neural network is looking at when it's answering questions or making predictions. That line of work is one of the few ones that has stood the test of time. A number of other methods were proposed 10 years ago that have fallen off to the wayside, as not actively pursued now. And then I got interested in agents that do things in the world, not just talk. And that took me actually to robotics, because that back then felt like the most natural instantiation of this idea of having agents that do things in the world. And I was also a professor at Georgia Tech, also a senior director at FAIR, at Meta, leading FAIR Embodied AI. So that's all of AI for robotics and AI for smart classes. One of my teams built a 3D simulator called Habitat. It was, when we built it, the world's fastest 3D simulator for training virtual robots, because we wanted to scale reinforcement learning. So we wanted robots to take actions in simulation almost like gameplay, except extremely sped up gameplay, so that you can go through decades of experience in just hours of compute time.
Got it. So basically, let's say if I have to imagine a cleaning robot, it can learn, clean some parts, come back while using computer vision, the Roomba robot. So something along the lines in smart glasses as well as in robotics.
Right. The connection between those two was that there was a reason why we were called embodied AI, not robotics, because our thesis was the problems you have to solve about understanding the world from a first-person perspective are the same problems in robotics. That if you build a smart glass where you have to understand what a human is doing while they're wearing the glass, those problems are very similar to what a robot has to do, because a robot also has to understand the world from its first perspective with cameras on it, to not bump into objects, to pick up things, to understand what distance to keep from another human, and so on.
And while measuring depth as well as accuracy in terms of image.
One of our bets was that humans actually can't accurately predict centimeter level depth anyway. So it was an approach of pixels to actions. Just take camera images, throw it into a giant neural network, predict motor control. So predict whether the robot should move forward, turn left, turn right, and don't try to solve hard geometry problems about predicting depth, then predicting the shape of objects, then doing path planning. Back then, there was tremendous resistance from roboticists for following this line of approach. The classical robotics approach, which is what Waymo was founded on, is that you build a map of the world. You, from cameras, try to predict where all the objects are, which is why Waymos have LiDARs, because they're trying to predict where the obstacles are. You build the map of the entire city. If you want to go from point A to point B, you do path planning in this map. The problem is that maps are outdated the moment you construct them. If something moves, then your plan is incorrect. And so our thesis was that you could just learn in humans don't actually have that great of a map. They certainly don't have a pixel or a centimeter level accurate geometric map in their head. And we were betting that robots don't need it either. You could just learn it in simulation. And we showed that you could just do that. So and we showed sim to real transfer. We would train a robot in simulation, deploy it on the Boston Dynamics Spot robot. That team took that demonstration to the White House Correspondents' Dinner in 2024 to show it to congressional staffers for what these robots are capable of and what's coming. So it was fun.
Yeah, this is brilliant, because wherever there is less predictability in terms of path, in terms of environment, reinforcement learning is very important.
I think a fun fact about Dhruv is that he's won a Best Paper Award or an honorable mention in every domain of AI, computer vision, NLP, like natural language processing, robotics, and just core machine learning, which I think there aren't that many people in the world who've done that. So
every level of AI.
Every domain, like every application, computer vision, natural language processing, robotics, just core machine learning / AI.
These are like separate conferences in each domain.
Oh, wow. So everything you touch brings you award. Now, that's why you chose him and later included in Yutori, right?
Both of them, right? Yeah.
I want to know, at what point of your work at Meta, you guys had the epiphany realization that it's now time to leave? Was it Meta losing track of their ambition? Was it you guys were more curious about your own ambition with Yutori, or you got an idea? At one point of time, you thought of leaving and founding Yutori.
To be honest, I don't know if it had a lot to do with Meta. I think we've had a weekly lunch going back almost 7-8 years. So back when I was a PhD student at Georgia Tech, that weekly lunch was called brainstorming, to brainstorm startup ideas. So it's not like we've met every week for 8 years just trying to come up with an idea to do a startup on, but the idea was that it was pretty clear early on that if we wanted to start something of our own, that we would do it together. And so it was meant to be a way to sort of brainstorm ideas on what that might look like. Now the reasons for leaving Meta and the timing of it, I think it's different for all three of us. Like for me personally, I've wanted to start something of my own for as long as I can remember. I considered it pretty strongly at the end of my undergrad, at the end of my PhD, with Devi and Dhruv. But then for various reasons didn't end up doing it at that time. And so it was just a matter of time when I embark on that journey.
So you wanted to become a founder first with your ideas, with your ambition, as compared to think of an idea that led you to leaving Meta. So it was always in your mind that one day I'm going to do it.
Yeah, and there's no shortage of ideas. There's a bunch of interesting problems in the world. So it was more the timing of when we decided to go down this path.
And you were practicing critical thinking and brainstorming every week.
I think for me it was so one is this common thread. The three of us have been talking about it for a while, so that seemed like it was more a matter of time than anything else. For that timing specifically, in my role at Meta, when I was a senior director, I had multiple teams. reporting to me, and sort of they had their own team leads. And it was a lot of exciting work that was happening. Gen AI was the top priority in the company at the time. So that was all fun. But I was starting to miss kind of driving things myself. Over time, my role had evolved into more and more of making sure the right people in the organization are talking to each other. Someone's upset about something, trying to sort of sort that out. And so I was just missing sort of driving the work itself. I had gone a little too far from just like what's happening on a day-to-day basis on the ground. And so that is what had triggered the itch of like wanting to figure out to change something, whether it's the role, whether leave the company or not. That was all within the scope of possibilities. But then intersecting with what Das was thinking, that just felt like the timing was aligned. And so both of us left Meta on the same day in March of last year.
So what you're saying is like having core effort of shipping things on a one area of expertise fast was harder at Meta. That's why, and you were so driven by this ambition of Yutori, and that led you leave. How about you?
I joined them 2 months after they left. I was doing robotics at the time. For me, it was people and problem in that order. I remembered doing some of the best work of my life with these people. And initially I thought, I'll join you folks as soon as a couple of these projects land. And then I saw them work out of our kitchen table. And it was just, it moves quickly. Things move quickly when, people who think on the same wavelength are just a small group of highly talented people can, I think, move mountains. And that was appealing. And then the problem, of course, I don't think general purpose in-home robots are close, but general purpose digital assistants that take actions for you on the web are not that far. And that's the future that I was excited towards building.
What future you all imagine with your work that you had never thought it would be possible? I mean, I have shared the use cases that I'm, so happy about, but there is some drive you all have of the ultimate future I want to know about.
Yeah. So Scouts is the first step, right? Like it's the first step in our journey towards proactive agents, proactive assistants that can take action on your behalf. So like the future that we are building towards is basically can be thought of as kind of like a task list with superpowers. That anytime you think of to do or a task that you have to do on the go while you're commuting or in between meetings, you jot it down somewhere. And then behind the scenes, there's like agents or assistants that are making progress on those tasks on your behalf. Even better if some of these agents or assistants can proactively notice what needs to be done and handle those tasks for you on your behalf, right? And so that's the future that we're building towards. Scouts is kind of the first step. A lot of these tasks happen on the web. Which is why the core capability on the research front that we are pushing towards are web agents that can do tasks on the web. And another way to think about this can be that like if I zoom out and think 5 to 10 years in the future, what interacting with the web feels like, we would be operating at a slightly higher level of abstraction, right? Like right now, we manually browse web pages, click buttons to get tasks done on the web. Just think of any chore that we do in a web browser, basically, right? But 5 to 10 years in the future, we'll be operating at a slightly higher level of abstraction, where we are talking to our AI assistants, telling them what needs to be done, and they are kind of handling it on our behalf in the background, right? So like I said, we would operate at a slightly higher level of abstraction. We would not have to sit there and watch these agents manually click buttons to, I don't know, book me a DMV appointment, right? So the whole paradigm of interacting with the web starts changing quite a bit. We're already starting to see initial signs of this, where there is an incentive and a push for websites to be more LLM friendly, right? MCP servers are coming up. At least the most popular websites have some version of them available that are easier for LLMs to consume, and that makes it easier for an AI assistant company like Yutori to be able to do more and more tasks and workflows on consumers' behalf.
Yeah, so I think what's motivating here is like to the thing that Das was describing earlier, that if you have these team of assistants that are sort of taking care of all of the mundane things for you, just that. So Yutori, the name, it's a Japanese word for the sense of well-being that you experience as a consequence of just mental spaciousness. So like not a lot of clutter in your life, not a lot of context switching, not a lot of pings coming your way. And so just sort of delivering that to many, many people in the world, right? If all of us can have more time, energy, space to focus on the things that are meaningful to us, and everything else is sort of just taken care of for you in the background, that is highly motivating.
On the digital front, Yutori's mission is quite clear that there are things that don't require humans to be mucking around. Like, why should you and I be sitting in front of a browser clicking buttons when machines can do this for us? We were supposed to pursue our interests and machines were supposed to do the grunt work. Turns out that machines are drawing pictures and writing poetry, and we are clicking buttons on browsers. That doesn't seem the right order of things. I think beyond Yutori's mission, it's clear to me that the future is one where more and more of labor, whether that's cognitive labor or physical labor, gets outsourced to machines. And you want to think of a future where you wear a sort of cognitive superpower and physical superpower where the interaction with the digital world and interaction with the physical world is amplified by an assistant that takes care of things for you. That when you want things ordered, when you want things orchestrated, when you want just objects moved around, when you want your laundry done at home, whatever, like physical labor, cognitive labor, all of those just have to be automated away. That there's no reason why humans should be doing this.
Can you pinpoint one thing that if your AI solution does, you will be proud? Your goal is accomplishment. Your goal is accomplished.
Yeah, there's a bunch of individual examples. It's hard to pinpoint one. And it's because of the nature of having an assistant, having a chief of staff. There isn't any one thing that you expect them to do. It's this general feeling that anything that I would rather not be dealing with is being taken care of. And that, like, because of its nature, is sort of a very broad surface area kind of a thing. Yeah,
there's a bunch of background tasks that are always ongoing in our personal or work lives, right? Like anything from like reservations, scheduling appointments, coordinating with people, having to monitor certain websites because there's a trip you're planning, or because you're looking to buy something but like it's sold out right now, or a discount is not quite available. And then on the work front, if you're trying to stay on top of multiple threads across different tools, email, calendar, Slack, Notion, etc., there's always a bunch of these background tasks going on in our lives, right? And the point of what we are building is to try and help take care of a lot of this so that you can focus on what's most meaningful to you. So it is by design meant to be a horizontal product. Now, it's not like it's going to be able to do everything on day one. We will gradually make progress towards it, but that's the idea.
I think of it as what happens after the dull and the dreary gets automated away. Well, you just have time to focus on the things that are not dull right now, but over time you will learn how to do them, and then they will become dull. When we first invented typing, maybe it was fun to type letters out, but after a while that became a dull and dreary job, and we automated printing and email and all of those things away. We're all sitting writing emails to each other as a mode of communication, and we spend time trying to figure out what time you're available and I'm available, and what time can we meet and where should we. That's now dull. Like, why should we be doing this? When that's freed up, you and I will be pursuing some other interests. Like, you'll be pursuing your interests of reaching audiences with interesting ideas. We'll be pursuing something else about reaching people and building something creative and interesting. And those things will occupy us. in the first few iterations, they will be fun. In the next iterations, we will figure out that there are dull and dreary aspects of that. And I don't think this mission in its full generality ever gets solved, because what does solved in its full generality mean? It means that there is nothing that humans want to do, and I don't think that's ever going to be the case.
That's a very good point. I mean, I want to imagine, I want to share the future, which I've already imagined. Like, I start my day and I read the emails from Yutori. It is great with summarizing what trends I need to keep track of as a creator. H1B, F1 visa, or Claude, Cursor, all these agents keep on rolling updates. My browser, I use Dia browser. I want to see the updates of things I like, not the scattered news, which I have to find information.
Yeah.
So that's my biggest advantage. Now, in this advantage, I want to ask about why cannot anyone else build it? Why and how you have perfected it? What I see is it can be achieved with MCP agents, but how you guys collected all the skill sets and research experience here to craft the solution?
Well, I think it's hard to get agents to work reliably, or at least it's hard right now, right? Like if you think of a task on the web as a sequence of steps or a workflow, like let's say there's like 20 steps or 30 steps or 50 steps involved in keeping track of like news on a specific topic. Even if these LLMs are like, let's say 90% accurate at each step, there's a compounding error problem where the 10% error rate compounds over a 20 step, 30 step, 50 step tasks, right? And so overall task success rates out of the box end up being much lower than what would make sense for a product to be actually useful. So a lot of our work goes into making sure that 10% error rate comes down drastically, where these tasks are much higher, like executed much more successfully, and the results are much higher quality, where it makes sense to productize them, right? And so under the hood of what powers Scouts today, it's a mix of MCPs, APIs, as well as browser used models. So for the websites where there's APIs available, our stack would use APIs to pull out the best results. And then for the long tail of websites where there aren't any APIs, it would spin up browser use agents that would navigate those websites like a person would to pull out the right information. And then there's checks and balances to make sure it does the correct thing at every step, at a task level, at a step level, overall surfaces the right results to users and so on, right? Yeah, evals, auto evals running on every query that gets run from any user.
I think the only thing that I would add is similar to a point that I made earlier, that there is information in the world that is locked behind interaction with web pages that you cannot just scrape, Google cannot surface that information to you because it's a sort of a search query that requires interaction with a database with the front end that is a website. Like, you want to know, there's an artist you're tracking. When they come to your town, you want to know, are there tickets available with, reasonably close to the stage, but within my price range? There's no website where you can read this information. It doesn't say that in text anywhere. You have to open up some service that is selling tickets or listing them or, reselling them. You have to go figure out who's performing when, which stage, where do you live, close to that, whatever. You have to go actually reach a seat map. And you have to see where in the seat map the stage is, and then maybe it'll tell you the price. And so this is an interaction with a database that is somewhere out there in the world, and you cannot reach this. And in order to reach this, you have to build either browser use agents that operate this like a human do, in which case then you have to understand how websites are laid out for human consumption.
Like, there's no consistency in the type of websites. And information is so scattered. Some websites don't allow their API to be shared. Some websites work differently. Some websites are behind a paywall, and still Yutori is free.
Yeah, I mean, to be clear, right now, our agents don't go beyond authors. So they only monitor public information on the web. But we're working on a few things where they will soon be able to go beyond authors and log into services on users' behalf.
So you mentioned about evals. What are the clear measurements of a agentic system you measure for accuracy, security, privacy, and how do you create that system?
So our evals happen at a few different levels of abstraction. When a browser use agent is clicking buttons. Those are action level evals. Those, as you can imagine, are sort of underspecified. You can click a drop down or you can type a search query. There are multiple ways of getting to the same information. So there's no single right answer. And then a browser use agent is basically a sub agent, right? It's been told to, you are on this website, fill out these dates and tell me if there's an availability or not. And it'll give you an answer. Those you can evaluate because it comes back with a proof of work. Mm-hmm. It shows you a screenshot and it says, right here is the date that or a time that I found. And those evaluations are actually, you can automate them because if the information is on a screen, you can read that information, you can verify. There's a verifier generator gap, basically, right? Verification is easy.
What is the gap? Verifier generation?
Verifier generator gap. So the browser use is generating a sequence of actions. But at the end of certain tasks, let's say you ask, is the 6:30 p.m. dinner reservation available at this restaurant? Solving that task is somewhat hard because it requires, going to that restaurant page or OpenTable, typing things into a date picker and so on. But if I show you a screen with those things already filled out with the 6:30 p.m. time available, verifying that is a lot easier.
Correct.
Because all the information is on this page. This is a certificate of proof. And we already have models today that can read this web page and tell you that, yes, this page shows what you claim it shows.
Wow. So the future is laid out correctly. Right now, we see just email alerts for what you want to do. But you guys are working towards the future when that action is not just an email alert, but completed as well. Because that's a harder part. Payments, confirming a reservation before you even take the permission from the user. So these are the hardest parts.
They're hard, but I want you to realize that in order to tell you that a 6:30 p.m. reservation is available, we had to go through partial steps of the reservation flow. We just stopped before actually booking the reservation. And so we have to go further in this trajectory to book it for you. But the reason for that is we don't want to serve a product where we can't meet reliability needs. So,
and this is something that users are asking for. Like a lot of times we'll send you an email that, oh, this is now available or the price has now dropped. By the time you see the email, by the time you click on it, it might not be available again. So users have said that, like, I wish you would just go ahead and book it for me, or you would just go ahead and buy it.
100%.
So, yeah.
And a lot of the point is to abstract this complexity away from users, right? Like users don't care what AI breakthroughs we are making or whether I won a dissertation award or not, right? They care about if the job got done or not, right? So all of this is stuff that we beat our heads about, and like we worry a lot about like whether these agents are working reliably or not. But on the product experience side, we take a very different lens that like, okay, is it getting the job done or not, regardless of what happened under the hood, right? If it's reliable enough to work on the very first try, then it starts making sense to make it available to users in as intuitive a manner as possible.
Or you guys focus on reliability, and till the time reliability is not achieved in actually completing the action, you cannot ship it. No tool out there has achieved that yet.
But a lot of them promise it. And it is on our minds to not be making the same mistake where like you put out a agentic product and say that it can do anything on the web, but then people try it and they're like, yeah, no, this can't do much. So we at least try very hard not to be yet another company that's making the same mistakes.
Absolutely. And since we're already talking about the features, is there any use case, is there any breakthrough with Yutori, or is there any breakthrough in general that users don't know about? It's hard to be known.
From like a capabilities standpoint?
That like, since you have the deepest, because we have 50 years of research experience here, there's some capabilities only that users out there don't know, to actually go out there, use Yutori to its full capability.
I think maybe one thing that is underappreciated among most users, not all, is the extent to which you can give it specific constraints and instructions when you set up the Scout. You can tell it that like, these are the specific websites that I want to be monitoring. These are like, if you're looking for apartments, this specific rent range, this specific neighborhood, all of these zip codes, sort of a lot of natural lighting and all of those things. The fact that you can be fairly detailed in the query that you set up I think comes naturally to some users, but I think most users don't realize that you can put in that level of detail.
That's a wonderful use case you mentioned. Finding a part Bay
Yeah.
Area as soon as it's available.
Yeah.
Wow.
It is one of the common use cases that people use it for. Yeah.
Wow.
And one of the things that some people realize but others don't is that you can specify things in natural language easily that a website would make it very hard for you to specify. So you can, for flight searching, say, I want to travel in November, December time period for 2 weeks. I don't want to stop somewhere here. So avoid these now, give me my options. If you had to do this on Google Flights or a website like that, there's no easy filter. You just have to keep selecting a start date, an end date, move it, keep a 14-day window, keep moving it 30 times, look at what the price is, avoid certain things manually because they're stopping somewhere you don't want to stop, and then just keep writing down on a file, what is the price, what is the price, what is the price, and then you can compare. Again, those are not things that you have to do as a human. We just gave you the ability to write in natural language, check every weekend for the next 6 weekends. Is there a restaurant available on this thing or not? You can do that with these agents.
And how expensive it is to build a startup in this space. You guys mentioned you guys have gotten funding from all the amazing people. And like you wrote it specially, 15 million funded, but not corrosively funded. So in this space, especially actively going and clicking on the web, like ChatGPT agent is expensive. You guys are free. How expensive it is. Like I talked to Cursor team. Cursor team spends $1,000 per developer in paying for the API of Claude and ChatGPT. So how expensive it is, and how have you mastered the skill to lower the cost?
I mean, to be clear, it's not going to stay free forever. Like we are pretty early on. The initial version of the product, the reason it was free was because the main thing we were looking for is feedback. That like this was a product concept that we put out in the world. Do people like it? What do people think? Is it useful to people? That was the main signal that we were looking for. But we are going to start monetizing pretty soon. To answer your question though, like if we had started this company a couple of years back, where some of these open source multimodal models did not exist, and we had to invest in training some of these models from scratch, then it would have been like really, really expensive. Like the funding that we've raised would probably not suffice if we had to do that from scratch. But right now is a particularly interesting time that there are really good open source multimodal models. And so we focus more on the post-training, mid-training and post-training side of things, which is significantly cheaper, requires fewer demonstrations to get to a level of capability and competence where these agents start doing reasonable and correct things on the web.
Yeah, and one thing that's and I know I've said this a few times, but the fact that we have the in-house talent to post-train, we're not pre-training, but to post-train models ourselves means we don't have to be relying on external APIs to serve the product, right? We can have our own models that we're hosting, which makes a significant difference in how expensive it is to serve the product. Which is different from many of the other entities that are out there.
And you can nail down to the, instead of fine-tuning an external model, you can create your own model, which would be cheaper because majority of the cost goes in API keys.
Exactly.
Like for some of the web, like the browser use capabilities, we train in-house models that power Scouts today.
Very nice.
Yeah.
Everyone becoming a founder talks about first principles. And, starting from the ground up basics. So what is your belief in building in the space of AI agents? What are the first principles and the skill sets needed to quickly build and that you have gathered?
Yeah, I don't know if these are skill sets necessarily, but just certain values that I think are important to us and we've said this, but like whatever we ship needs to be reliable, it needs to work, and it can't be a tech demonstration. It is not like Das was saying it. The user doesn't care that there are agents or AI or whatever is behind it. If you are trying to monitor your genes availability, all you care about is did it tell me on time, and was it accurate when it told me that information or not, right? So thinking very heavily from what is it that the user cares about, what is the least friction way in which they can get the information that they need, designing the product around it, thinking through the product use case in a way that's aligned with model capabilities so that we're not shipping something that's unreliable. That is very much top of mind for us, and we take that quite seriously. Attention to detail goes hand in hand with that, that everything that goes out is very heavily tested, whether it's evals on the modeling front, even just a whole bunch of internal testing and dog fooding on the product before it's shipped. All of these things are quite top of mind in how we operate.
At any given point of time, there's about tens of different experiments that we're dog fooding internally, and maybe one of them will ship in that week to the production product, right? So a lot of it, like evals is one side of it, but especially with agents, with LLMs in the loop, evals are somewhat of a laggy indicator. Like once you discover a category of mistakes, you build evals around it, then you can hill climb that. A lot of intuition comes from just testing out and dog fooding the product on a week-to-week basis, basically obsessing over that.
Yeah, I think it comes down to a difference between, which is where I think this conversation is going to go, doing things for yourself versus doing things for others. You learn for your own improvement, but you build a product for someone else. And they do not care about how much work you've put in. They do not care about whether you had fun doing it, whether it was fast, whether it was slow. They care about whether, first of all, you have to develop an empathy for what do they care about. And second of all, they care about getting their thing, their problem solved. And that's what partly this takes, that, understanding what someone else is. An example that Das used to give is, why is it that the feature of reading two-factor authentication code that is sent to your phone so loved by everyone, that when you're trying to log in somewhere, the fact that you get a text message and if your phone automatically reads it and fills it in, why is there such a loved feature? Because people, it's a cognitive load. I'm just trying to move on to the next thing. Don't make me stop in the middle of this, go somewhere else, memorize a number, come back, type it out. You have this information. Why are you making me press this extra button? And so, like, where does that empathy come from? You just have to think about someone using this product. Every extra button click, why are you making them do it? Why don't you solve that problem? And I think that is extremely important when you are building for someone else, and most of the world is other people. So you do have to build for someone else.
Got it. So it doesn't matter what tech stack, what skill sets is coming, people are coming with. What is important is getting the stuff done. So that's basically at an early stage startup we care about.
Yeah, I mean, the other stuff matters in the sense that, like, it's the how you get there, but the user doesn't care what your tech stack is, for sure. Yeah.
And since you all three have a very strong team, do you think you need more? How big is the team building Yutori?
We're right now 18 people plus interns, 18 including the three of us. Yeah, roughly evenly split between like agent infra and research and product engine design.
Oh, very nice. And especially in a very creative startup, like the idea which I've never seen before, it blew my mind. I needed it. I never saw any other startup doing. What do you look when you hire someone in this creative space? Because I don't see any competitors you have, right?
You're right. I mean,
is that true?
I don't think that's fair. Like,
the big AI labs would beg to differ.
Yeah.
Really?
There's a ton of players building agents, right? Like there's a ton of companies building agents. Maybe if we slice it narrow enough where we look at scouts and a monitoring product like that, yes, maybe nothing else quite is going after that use case. But agents generally, I think a whole bunch of companies are building in this space.
Yeah, that is true. But like, especially this use case that is very niche, no one is doing it.
Yeah, I mean, like ChatGPT has scheduled tasks. Perplexity has a version of that as well. It is not quite the same as Scouts. Like, you can't condition it on an event happening in the future to then get a notification. It's much more like every day at 9 a.m. do this or something of that sort. So yeah, I think it is true. I don't think there are other products out there that are like Scouts. But if you think about assistants in general, agents in general, there's a whole lot happening.
And the intuition here was that, like, there are a lot of tasks in our lives that have this monitoring like flavor. And so it is a bit of a latent need that no product directly addresses, which is why we thought it would be a good idea to go after it. And agents and the level of reliability we can get to is all like well aligned with this use case. It's still a horizontal use case. It's still an entry point to these agents being able to do tasks on your behalf.
And it's a read-only task where the risk of mistakes is low, because it's not like you will accidentally buy something that someone didn't intend to and so on. You're not going past auth walls. Those are good places to start, because as I'm sure we're going to discuss, the most valuable thing in AI today is data, right? If I am serving a product that is hitting more than 20,000 websites, and I know what people are asking for, and I'm serving agents that are going to these websites, taking actions, I can tell where these agents are succeeding. I can tell where these agents are failing. And that becomes the flywheel on which I can improve performance over time. And if you don't have that flywheel, which, by the way, I'm sorry, I keep going back to robotics, but that is the main problem with in-home robotics, for example. It's very hard to get started because you need to reach someone's house. You have to deliver that first piece of value for which they will spend $20,000 on the robot, and they're not going to do that. But a software product where you say, I will provide you a little bit of value. You don't have to log in. You don't have to trust me. You don't have to give me your credit card. I will monitor this thing for you. That gets you the data flywheel from which you can do all sorts of like supervised fine tuning, reinforcement learning, whatever you want to do from there.
And with that data advantage, you can achieve so many things which are now possible. Now, in this space, with the strong team of 3 researchers you are, what do you look in a good engineer or good researcher while hiring? How do you define a good researcher or good engineer capable to work here?
I think it's hard to articulate. It is a little sort of vibes based, right? But I think someone with a track record of having delivered, I think signs of just agency, that they will be excited about whatever piece that they're owning, and they'll sort of want to deliver on that, push on that. Clarity of thought is another thing that we care about quite a bit. Yeah, I don't know if there's more to add.
I mean, it could be coming from your journey when you chose Das as your researcher working under you.
Years, I used to have an FAQ on my webpage when I was a professor that, answering a question of what do you look for in a student. Now, admittedly, a student is a different archetype. That is not the same thing as a person in industry, but I can give you that answer. Like what I would look for in a student are clarity of thought. Do you make leaps in the middle of a conversation? Does the idea of contradictions bother you? Does the idea of non sequiturs bother you? Do you notice non sequiturs in what you are saying?
Non sequitur, what is that?
Non sequiturs are things that don't follow. You say A and then you say B and then you say C, but B doesn't follow from A and C doesn't follow from B. And there are
ADHD, switching topics.
Either switching topics or not realizing that there are holes in your argument where you're making extra assumptions. The A plus something else takes you to B. You didn't say that plus something else. You assumed that we both agreed on it. We didn't agree on it. And yeah. So the idea of non sequiturs bothering you, the idea of ownership, as Devi said, does the idea of crap out there in the world with your name on it bother you? That's extremely important. Like, does when you say you will get something done by some date, does it actually get done by that date? And it's okay for that date to move. You can say again, you can replan, but is that something that bothers you? And ultimately, research is about exhibiting a certain degree of agency and creativity. Nobody knows what the right answer is. Nobody even knows in research what the right question is. All we know is that there are boundaries beyond which we can't see, but we know there are things that we don't understand. We can't even articulate what it is that we don't understand, because if we could precisely articulate it, that's most of the way to getting to that answer. And so research, and maybe in that sense, it does share a lot with, even building new products in industry, where you just have to have an instinct for where the holes lie. Nobody's telling you that there is a hole right here. I do not understand this step in the theorem. That happens in a homework problem. That doesn't happen in research. In research, you just kind of notice that nobody seems to talk about this. People jump over this because we don't know what lies there. And you have to boldly head into that direction, figure things out, draw analogies from other areas, work from first principles, use whatever creative methods you have at your disposal, and have a certain sense of belief that you'll just run enough of these iterations to be able to figure things out.
That's a very important point, because most of the students out there, like, forget PhD, they're dropping out of college. They're devaluing the importance of education since the wave of AI. Everyone wants to build a startup, quitting college. And you guys pursued your PhD and continued research for years before founding a company. So what is your perspective on that? Like, because I want to emphasize the importance of learning for the young people out there.
I do think like learning is important. I don't think there's a way of bypassing that. There is a conversation to be had about whether, especially for PhD, I think college, might still be sort of the bar that's worth sticking to. But especially for a PhD, it's worth being clear on why someone is doing a PhD, right? That is it, like, do you want to become a professor and you can't get a job as a professor unless you have a PhD, and that's why you're doing it? And even like, if you want to be a professor, why do you want to become a professor? Do you enjoy teaching? Do you enjoy mentorship? Is it the academic freedom in the research? What is it that you care about? It is not the case that the only way to contribute meaningfully to AI or even to underlying models is through a PhD, right? There are multiple ways of getting to that point. Learning is required, but a PhD is not the only way to learn, right? There are other ways of learning as well. So I think that clarity on why you're doing what you're doing and whether the path that you're choosing is the only way to get there, I feel like people don't often think that through.
Following up on that, since you have expertise as assistant professors, how would you change education if it has to be done without college? Because we're going the same path. You mentioned the advice you would give is curiosity, having a consistent path, and delivering on time, autonomy, which is agency and autonomy, very important. You need to be self-motivated and mission obsessed. So how these things can be learned without college?
So I'll answer that question in just 1 second, but it is worth taking a step and asking, why do we send young people to colleges? Like, why do we encourage them to do that? It is supposed to be, for a bachelor's program versus PhD, those are two separate goals. The bachelor's program is supposed to give you a broad foundation in a body of work so that you understand what is known about that body of what has humanity figured out. What has humanity figured out in the area that you are interested in? And you, in some sense, are getting an accelerated pathway. We tell you exactly what we have figured out, and we get you to be a competent, contributing member of society that can push those frontiers, build new products, go decide to do new research, go do new endeavors. The reason why we are in a difficult spot today is that perhaps 4 years feels too slow right now. And let us have some empathy for our colleagues at universities. They are struggling to deal with interest in computer science and AI, while at the same time, their regular methods of pedagogy have been challenged. Like teaching. Like, how do you actually evaluate somebody's understanding when what AI has done is made it very easy, and chatbots in particular has done, is made it very easy for them to submit a piece of work without them having developed that understanding. I think this is transient. We will figure this out, just like we figured out how to overcome past challenges. But there will still be a place where, and this is where PhD programs were originally designed, you go into a PhD program because you want to push the frontiers of human knowledge. We do not know. Nobody can tell you how to do a PhD. Nobody can tell you exactly what to do, because every PhD is unique and new. Because every question that you end up answering is a new question. Nobody has done that exact same thing before. And if you just want to go through a newness experience with a structure of a program that gives you 5 years to just invest into yourself, then you should go do a PhD. In certain areas, it is hard to do a PhD because the resources aren't available. Like, if you want to train LLMs today, perhaps don't go do a PhD. You just don't have the resources available in universities to do pre-training. Similarly, if you want to do particle physics, unfortunately, universities don't have the resources to be able to have the best access to accelerators. You will have to go to either CERN or other such efforts where there is accumulated pooling of resources.
So you're saying education will automatically evolve, because currently we're living in a world, even researchers, if they craft an Olympiad question, math Olympiad, or like collegiate like programming Olympiad question, which takes months to craft, it's unique. No AI, no internet has seen that problem. AI is able to solve it at 100% accuracy. ChatGPT, Gemini, they solved all of them with 10 attempts, all of them. So it's impossible to differentiate. And right now, as you mentioned, the only way to trust your abilities to ask questions, which is not scalable, soon it will automatically improve. That's how education will evolve. We will figure it out. And what still excites you about education, PhD, if you would like to share experiences that blow your mind, so we can excite the people watching about research, which is so exciting that they can also take part in this, in your journey.
Yeah. So I think my time in grad school is the time when I've had the most fun. It is 4 or 5 years of you just figuring out what you're interested in, what you're not interested in, what your work ethic is like, how you like to operate, just getting to know yourself better, a whole bunch of self-discovery, making good friends that end up being lifelong friends. I think all of that happens in grad school in a way that doesn't happen in most other phases of life. So yeah, I wish I had stayed in grad school longer. And I guess, yeah.
Yeah, I mean, for me, I think the meta skill. So I had a lot of fun in my PhD as well, and like the meta skill that I think learned to quite an extent. There were a few different things. Like one is just the scientific process, how that works, right? Like coming up with hypotheses, designing the right experiments to validate and validate them, moving on to the next question and repeating this loop, right? I didn't have experience on that front before my PhD, and I got a chance to like explore this in many different domains as part of my PhD. And I think that meta skill generalizes to a lot of other areas. Like even when we're building a product, right? There's a whole bunch of questions that we have to figure out in our pathway to like building the next set of capabilities, the next product, finding PMF, etc. Right? And all of them take this flavor, this scientific method of like coming up with hypotheses, designing the right experiments to validate or invalidate it, and then moving on to the next hypothesis, right? So that was one thing. Yeah, maybe this is not that much of a meta skill, but when I started my PhD, I was, and I had, I think, conveyed to Dhruv, like I was pretty clear that like I was, it was pretty clear to me that I was having a lot of fun doing research. But whenever I stopped having fun, that I would drop out. Like I didn't start a PhD thinking that I have to complete it. Like it was a new space I was working in. I was learning a lot. I entered it with the mindset that, okay, I'm going to try and absorb as much as possible because there's just a fire hose of information here and things to learn here. I ended up enjoying it so much that I did complete it. But so that could be another perspective that like, as long as you're learning and having fun, I think it's good. You don't necessarily have to complete a PhD.
I think we're trying to make a case for not dropping out.
Yeah, exactly.
Yeah.
But sometimes you end up having so much fun that you do end up completing it. So if the activation energy of like that this is going to take 6 years, and so I don't even want to enter a PhD, if that feels too high, maybe just enter it by relaxing that assumption and constraint that like you're just giving it a shot. It's an experiment. If you're having fun and if you like it, you continue. Otherwise, giving yourself the option that it's okay to drop out sometimes leads you to complete a PhD, and things turn out okay.
Of Jeff Bezos' one-way door argument, right? That
it's not irreversible.
Yeah, it's not irreversible, and sometimes you can convert seemingly irreversible things into irreversible things. If you don't have to treat it as a fixed year commitment. You can treat it as a 6-month commitment at a time with 12 renewals.
and so just get started and see where it takes you.
I mean, you guys are normalizing it. Oh, it's fun. Have fun. Otherwise, leave it. Of course. But you guys don't realize that you are so important in the space of AI. Like there is extreme shortage of high quality researchers like you. So I want to like know what makes a different version of like Das, Devi, and Dhruv. Like what it takes to build someone like you. What is the highest and lowest points in your life you have experienced to become what you are today?
I think some of it is just reps, like just putting in the time and effort and just sort of everything that you're doing it to the fullest extent and just keep going for a while, right? I think, yeah, I don't know if there is kind of a magic formula to it. I think it takes a lot of time and effort and interest. Like the only way you can put in a lot of time and effort is if you're enjoying it, right? So you want to pick the path that appeals to you in some way, which then motivates you to put in the time and effort. Yeah, it's not particularly insightful, but I feel like,
I mean, for whoever thinks that there's ups and downs in research, there's way more ups and downs in building a company. So like, I think that skill of just showing up every single day, that's it. Right? Regardless of the ups and downs, you just have to show up every day and keep making progress, right?
So for stability, you would rather be in Meta than building the company.
I mean, if you're optimizing for stability, yeah, for sure.
Like, Meta's not going bankrupt tomorrow. But
Neither are we. To be clear. Yeah.
But 9 out of 10 startups fail to transition from seed to Series A. 95% of startups probably fail regardless of where they start.
And so you see those stats in the face and you still choose to do it. And like what Das was saying, you sort of wake up every morning and just keep showing up regardless of whether it's the high of the roller coaster or the low of the roller coaster. Right?
There's a bodybuilder whose name is escaping me right now. He has a famous quote, everybody want to be big, nobody want to lift big ass weights. She just started.
So true. So what's the hardest thing you guys have worked on in your research journey at Meta or during your PhD that you're most proud of?
Everything that you end up accomplishing, it's very easy for us to normalize it very quickly. That like, yeah, that wasn't that hard, right? So it's, there's a little bit of that happening, I think.
Yeah, and it's like different things. Like there are some things that you just had a lot of fun doing and nobody else cared about, but you're still proud of it in the sense of like, I enjoyed it and I gave it my best and I like it regardless of what others think. And then there are some things that a lot of people have recognized and find valuable and just has had lasting impact on the field. So I feel like there are different things in different categories. So I can just give you a few examples of this. So I had done this project with a collaborator, Larry Zitnik, who's still at Meta, way back when, where we were working on these cartoon images. And this was like right when deep learning was starting to take off. So it was like 2013 or so. These cartoon synthetic images where like it was very unclear how whatever findings we have from this would make much of a difference in computer vision. But it was just a really fun project. Larry and I really like working with each other. We wrote a paper on it, submitted it, became an oral at one of the computer vision conferences. And so that it was just a fun project. I would have thought it's hard to get a paper like this accepted, and the paper was accepted. It was well received. And so, but I don't think it made a major dent in the field, but it's just one of my highlights of something that I've enjoyed, right? So that's like one category. Another category of work is the line of work on visual question answering that Dhruv and I had worked on. Das had also worked on it for a bit, which was then extended to visual dialogue and things like that. But that data set we had released in 2015. To this date, it is used to evaluate all of these multimodal capabilities that are released, whether it's OpenAI, Google, Meta, other companies. It continues to be used. The benchmark that we had set up continues to be used. We've run a series of workshops and challenges on it. We've written a whole bunch of papers. And so like going back to when I started my position at Georgia Tech and Meta, it was based essentially on my work on visual question answering. So like most people at the time knew me because of that, right? Like that's the basis of why I was reasonably known in the field. And that's actually we're going to get the Mark Everingham Prize at ICCV for this line of work, right? And this is like it's a 10-year later thing, has a bit of a sort of a having stood the test of time kind of a thing. And so that I feel proud of, because I do think it made a difference, and sort of a lot of people know about that work. Right?
Like how, if you have to name it?
Say more, like what do you mean by how?
Now, how, like if you have an example of how it impacted, so you want to add on?
So it's a whole, like a lot of the multimodal research that is happening, like everything at the intersection of vision and language, a lot of it traces back to this early work. It wasn't just us. We were working on VQA. There were a few other groups also working in this space, but all of that traces back to 2015 or so, which now we just take for granted. Now we just take for granted that these models are multimodal, but at the time there wasn't a whole lot happening in that space.
That was a time you all pioneered in that.
Along
and we
with
take it
some
normally
others.
multimodality.
Yeah, exactly. And a third example that is of a very different category is we were working on video generation models at Meta, and this was past sort of DALL-E 1, DALL-E 2, and so like the whole excitement of Gen AI had started. So highly competitive. Any day, OpenAI, Google, anybody else is going to release a video generation model. So sort of very high pressure, very high attention to this space. And we had put out Make a Video, which was one of the very early video generation models that worked quite well. It was like a significant leap in terms of capabilities. And so that sort of, we're proud of that for a different reason, that we got it out there before other people had it out there. And that had a good amount of visibility as well, right? So these are all different flavors of things that are sort of high points of the stuff that I've worked on.
Now, last topic I would go through is your backstory. So coming from India, for all of you, getting into research, how your interest grew into AI, ML, and a lot of people can connect because they're coming from India. Less people are coming to the US for research now, but they're still going somewhere, let's say Germany. So, but how your interest connected into the world of AI?
I can start. So I came to the US for my undergrad. So I grew up in India. After high school, I came to the US. And in about the third year of my undergrad, there was a new professor who had joined the department. And he was working on pattern recognition, is what we were calling it at the time. This was the ECE department, not CS. And so he was looking for students to join his projects because he was new. So he hadn't been around before this to recruit students. And so I was somewhat arbitrarily assigned to that project. And that's how I started working in the space. I had a lot of fun working on the project that semester. So I kept working with him for as many semesters that I had left in my undergrad. And that was fun enough. So I wanted to continue doing that in grad school. Actually, a little bit similar to what Das was saying. When I went to grad school at CMU. And when I had applied for the master's program with a research component. So the master's thesis program, because I didn't know if I wanted to do a PhD for long enough. But that year, they got rid of the master's thesis option.
So I did a PhD.
And so whoever applied, they either slotted them into the master's course only option where there isn't research, or into the MS/PhD program. And I ended up getting slotted into the MS/PhD program. And so I had told my advisor that I had just applied for the master's program. I don't know if I want to do a PhD. And he was like, just give it a shot. You will see that you will end up liking it. And so, yeah, that's how I was in that. I continued to have fun, saw it through to the end of the PhD, and then it's kind of one step leading to the next.
Wow. So you experimented your career that led you to PhD, and now, world's renowned researcher. Wow.
Yeah. What's relevant here, though, is that for many years, AI wasn't that exciting, right? Nobody cared about computer vision. Progress wasn't very fast. You'd go year after year to conferences. Accuracies are going up by 2% right now. Every month, there are new breakthroughs. But because I was having fun and I was interested in it is why I stuck through it, right? It's not because I knew that someday people are going to make $100 million in this space, right? That's not a thing that you can foresee. So there is something to working on things that you're having fun with. And that's how you can sort of keep showing up. Otherwise, if you're motivated by something that's a little too extrinsic to you, it's hard to stay motivated when the lows happen. Yeah.
100%.
Yeah.
I moved to the US in 2005 to go study at CMU, Carnegie Mellon. I had applied to a master's program, same as the program that Devi had applied to. And I was in the coursework master's program initially, converted into a PhD program. And really what attracted me to stay was the quality of people and the coursework that I had access to and the research that I could do by staying there. When I had arrived, I didn't quite know what I didn't quite know what computer vision was. I didn't know what machine learning was. I may have heard of AI, but I was more familiar with pattern recognition and image processing, which are terms that are used typically in the ECE undergrad.
Just like Devi.
Just like Devi. But it was just so much fun to learn from people who were operating at the cutting edge of their fields. And as an example, I'd taken an undergrad algorithms class with Manuel Blum. He's a Turing Award winner, works in algorithms and theoretical computer science. And he taught us, and it's fairly common in undergrad curriculum, to teach a linear time median finding algorithm. Given a list of numbers, n numbers, find the median number in this unsorted list. And the best algorithm for doing that is order n. You can't do better than order n. And after teaching us that algorithm, he sort of casually mentioned that he had invented that algorithm in the 1970s.
Wow.
Which is, subtle flex.
So Alan Turing Award winner person taught you, that excited you to move closer towards PhD and actually go for it.
Yeah, that, and there were other people who were operating at the cutting edge of computer vision, robotics, machine learning, probabilistic graphical models, and just a level of enthusiasm, a level of understanding, and a level of being able to express that knowledge and convey it to someone else can often change trajectories. And so I'm quite grateful for that.
Absolutely. So we can tell you all were passionate about what you were studying in your undergrad or masters that took you closer toward research. Right now, so many people are obsessed by whether it's salary, whether it's green card, whether it's EV1. So I think most important is everyone to have fun during your undergrad. Go for it. Go for education. And what final advice you would have for anyone watching this podcast?
Yeah, I think just put in the reps, like pick something that you're excited about. It doesn't have to be your purpose in life or like the one thing that you're most passionate about or anything like that. Just pick something that you're passionate about, take action, interact with the world, just put in the reps and keep going. And I feel like more often than not, good things come of it. Yeah.
Well, it's hard to directly translate advice from a different era when we went to grad school or undergrad. There weren't the same opportunities there weren't labs doing AI. So, these are not decisions that we personally made. And so every individual operating in an ecosystem that is different will have to make different decisions. But perhaps the meta skills that transfer over are if you engage with the world with a certain sense of curiosity, there are plenty of things to be figured out. And if you operate with a sense of agency and urgency, I think generally more often than not, good things happen. And so perhaps those are the characteristics to look out for.
Yeah, absolutely. Agency means you should be self-motivated and take help online by yourself. Be independent before taking help from others, and discuss ideas later on after doing your own homework. And
yeah, I don't know if I have something super insightful. I think just going back to what I said earlier, that like a lot of things that people end up thinking of as irreversible decisions are actually quite reversible. So just it's a pretty amazing time to be alive. There's so much new technology to build and being built every week. So just try more things, experiment more, figure out what gives you joy, what gives you fun.
that's a wonderful lesson. So risks that people fear taking that are way lesser of a risk than they expect. So irreversible decisions are often reversible than people think. Wow, that's a great way to end the podcast. Thank you so much for 2 hours of your incredible, important time. And everyone watching, please check out Yutori. It has saved so much of my time and it changes lives. Thank you.
Thank you.